Hello Year 10, we're going to look at feedback from your assessment. Please put the heading feedback and physics in your book now, please. So one of the questions that you had a misconception with was current. A current is the flow of electrical watt, and you had to fill in the missing word. You had to get the missing word. So some people put electron, and electrons do flow in the current, but current is the flow of electrical charge, the force that pushes that current around. So if you could just, in your book now, write down this heading misconception and explain. Electron is a stable subatomic particle. You know that it has a negative charge and it's found in an atom, and it acts as a carrier of electricity. And electrical charge is the physical property of matter that causes it to experience force. So could you write number 1 and 2 in your book? Pause the video and then continue when ready. Right, and then number 3 was a very long question. Describe how you would use, not question 3, but it's a misconception 3. Describe how you would use the change, or how you would use and change the circuit to investigate resistance. Now, we did a lot of practical with resistance in a wire, resistors. We looked at different resistors. So you need to refer back to this diagram, or this circuit, for example. Here's a circuit with a number of batteries. There's a resistor in it. And for example, we did the thickness of the wire. We used a piece of apparatus to measure what is the current or the potential difference in that wire, and we used an instrument to measure the current in the circuit. So these are the kinds of things you would have had to write down when you did this experiment. So to show resistance in a wire, what is the equipment? Yeah, we have a voltmeter and an ammeter. So you have to name that. You have to say what is the purpose of each of these. So an ammeter is used to measure current, a voltmeter is used to measure potential difference. So there were a lot of marks. It was a heavily marked question, and some people, I don't know if they just went blank. And then of course, how do you arrange an ammeter in a circuit? Well, you have to make sure that it's in series, completing the circle. Whereas a voltmeter must be across both points of the resistor. It must be attached to each point of the resistor. So it must be in parallel. So I'd like you to draw the circuit in your book, and then I want you to answer each of these questions. This is a guide to help you write your paragraph. Name the apparatus to use to measure current. Write it in 4 sentences. What do we use to measure potential difference? So how do we attach the voltmeter? How do we attach the ammeter? And if you remember, every time you had to lengthen the wire or change a resistor, you had to do something to ensure safety. So what did you do? Having a look, we didn't have a switch as such, but we could just disconnect. And then how do you calculate resistance? So I'm going to ask you to draw this circuit and answer question 1 to 5 for now in your book. Pause the video and then we'll continue. Right, so to calculate resistance, this was also part of the question. I'm going to go back to looking at resistors in a circuit. If there are 3 or more resistors in a circuit, To get the total resistance, we put 1 over R1 over R2 over R3. So if I had to have an example of this, there's 10 ohms, 10 ohms, and 33 ohms. So you could use a calculator to find out 1 divided by 10, 1 divided by 33. And if you used your calculator to measure this, you would find out that 1 over R, which is the total resistance in a parallel circuit, is 0.1 ohm plus 0.1 ohm plus 0.03. And you'd have a final answer of 0.23. Now that is just the calculation, but it's 1 divided by 0.23 ohms, and you get a final answer. So this would be in a parallel circuit. The series circuit is a lot easier as we add resistors, and they're in series. The resistance is just added together. So for example, if this is 100 ohms plus 82 plus 1, you're going to get 183 ohms. Can you draw a table in your book and you do these two examples? Draw the diagrams of the parallel and the series resistors, an example of how you do the calculation, and actually to practice that. If you need to pause the video and do this in your book, please. Going through some useful vocabulary or terminology. An ohmic conductor. So the question was, can you give an example of an ohmic conductor? And an ohmic conductor, just to define it clearly, is anything that conducts electricity in proportion to applied voltage. So, for example, it could be a lamp, a filament, a diode, a thermistor, or even the copper wire that we used in the resistance experiment. And then what is potential difference? It's a measure of how much energy is transferred by each charge between 2 points in a circuit. So can you define those two terms, please? Pause the video, do this in your book. Right, we're back at this. Looking at some direct technical information. You were asked to do the equation for resistance. And again, people seem to go completely blank. Remember the triangle VIR? Resistance is equal to voltage divided by current. Some people were talking about charge, but that is not the actual equation. So resistance equals voltage divided by current. You need to do that in your book, please. Number 2, you were asked to identify the symbol. What was this symbol over here? And this symbol is a light-dependent resistor, LDR, abbreviated, or similarly photoresistor. So can you please draw the symbol in your book and write down what it stands for? And then one of the questions you got asked is, why does the heating temperature not change when the heating curve between point D and E. So here is an example of your table. This is showing temperature increase on the y-axis, and on the x-axis it's over time. So this had to do with change of state. Now temperature increases gradually from a solid, and at B it's changing. It tells you here that it's starting to melt. It's changing from solid to liquid. And the temperature stays constant. And the reason for that, the temperature is actually fixed, is because the energy is actually being given to the particles themselves as they start to vibrate faster and try and separate. Between C and D, the temperature rises again once this ice, for example, solid, has changed into a liquid. It remains a liquid between C and D. And at D to E, it then again changes state. And the question was about this point here, D to E. The particles are moving faster. They've got constant kinetic energy, but the potential energy increases. And the temperature does not change. So can you draw this graph in your book and list all the different points and write this explanation in your book to do with change of state. Pause the video. Okay, and then one more question to do with dirt. Use the IV, which is current and potential difference, to name the component that is an ohmic conductor. So Ohm's law is a law that states that voltage across a resistor is directly proportional to the flow of current. That's the law, okay, or the rule. So you must know that it's a resistor. That's all you have to be able to say, resistor. We've just broken down the question. If it's already given you current and potential difference, they really want to know what's the other reading, and that would come from a resistor. So can you please write this last one down? Pause the video. Right, you should have been able to finish this. Name the apparatus used to measure current. It's an ammeter. You can mark that in your book now. Apparatus used to measure potential difference, the voltmeter. Number 3, explain how to attach the voltmeter in a circuit. The voltmeter is always parallel to the resistor. Parallel. And then the ammeter, how is that connected? It's connected in series, within that circle, in series. Risk assessment, every time we change a resistor in the circuit, what should we do? We should switch off the electricity or disconnect so that it does not overheat. You might have said keep it away from water sources because you could get electrocuted. And never handle electricity without switching it off first. Any of those would have been fine for a while. And then we've already gone through how to calculate resistance. So in your book now, I'd like you to do the calculations for 2 parallel circuits that are shown here. These are examples. And then these 3 examples for series circuits. Then you pause the video and work out the answers to these resistors in this parallel and series circuit. Right, so here is a series circuit, and we have 3 resistors. Do you remember what you do? Okay, so what is the total resistance of the circuit? You should be able to add these three together. If the voltage was 12 volts, can you work out the current? So now this is actually going back to use Ohm's law. What is Ohm's law? Do you remember? Potential difference is equal to resistance times current. So you would use Ohm's law to calculate this. You've been given the voltage, you have to work out current, and you've already worked out resistance. So you should be able to do question 2. And then can you explain how does resistance change if these resistors are placed in a parallel circuit? So if you could imagine 3 light bulbs here, what would happen to the light bulbs, or the strength of them? And if they were then in a parallel circuit, because this is what the question is, what would happen there? Calculate the resistance for these components in a parallel circuit. So going back quickly to this rule, how do you calculate resistance in a parallel circuit? So, and then, do you remember to draw a graph for a light dependent resistor? It's one of the questions from your test. And then list 4 factors that affect resistance in a wire. What do you remember? So you might look back in your book to help you. So I've just added this other question to do with resistance. Can you pause the video and complete these 6 questions? Right, talking about parallel circuits, it contains more than one loop, you already know that. And in a parallel circuit, the potential difference traveling through each of these light bulbs will be the same. So I don't know if you recall that potential difference in a parallel circuit is the same. However, in a series circuit, it is shared. So in a series circuit, if we have to put these 2 lamp bulbs together or next to each other, you'll find that the light becomes dimmer. Whereas in a parallel circuit, it would remain the same strength. Could you write down, draw these 2 examples of the circuits? This one is a series circuit, and the other one is parallel. And you're going to draw them and just write the explanation. You can abbreviate this. Please pause and do that now. We're going back to your questions to do with resistance, so we're marking them. Remember that in a parallel circuit, total resistance equals 1 over R1, 1 over R2, 1 over R3. So you've got to divide 1 divided by 10, 1 divided by 22, 1 divided by 47. And you add each of those together, and you divide it by 1, 1 divided by the total, and you should get 5.95 ohms. Try to always include the symbol of measurement. Right, number 2, we had 100 ohms, 33 ohms, and 560 ohms. Remember, it's the total equals 1 over R plus R1 over 1 over R2 plus 1 over R3. And you should have got this answer. So just check your answers and make corrections. And then this was a lot easier. The series circuit, you simply add the different resistors together. 1000, 1470, 1492 in total. And the second one, answer is 2242 ohms. And then the third question, 4847 ohms. Please do any corrections. Right, I'm going to attach your questions for your assessment. So you can read through the questions and you will get the memorandum with it. And then on Wednesday, we'd like to have a virtual question and answer session. So please email any questions that you'd like me to answer for you so I can prepare. Thank you.